Okay, in chapter 1.6, we're going to be going over several more properties of real numbers here. So we're going to start with the commutative properties. So there's going to be kind of like two of each for the first two properties, addition and multiplication. So the commutative property of addition essentially means if we're adding two numbers, the order doesn't matter in which we add them. So a plus b is going to equal b plus a. So what that means is, for example, 2 plus 3 equals 3 plus 2. So we know that's true, right? Because they both equal 5, so it's probably painstakingly obvious, but that's the commutative property of addition. The order doesn't matter. For the next one, for the commutative property of multiplication, essentially it's the same concept except with multiplication. A times b equals b times a. So when we're multiplying two numbers, it doesn't matter which one comes first. So this would be something like 2 times 3 equals 3 times 2. So those both equal 6. So remember that multiplication is just repeated addition. So for the left-hand side here, for 2 times 3, that means we are adding 3 together 2 times. So that would be 3 times 3, which is 6. On the right side, 3 times 2, that means we're adding 2 together 3 times. So 2 plus 2 plus 2, which is also 6. Okay, so probably pretty obvious, but they are important because they don't always hold with other concepts in math, but for numbers, they will always hold. So for example, let's use the commutative properties to write an algebraic expression equivalent to each of the following. So the first one, we have y plus 6. So that's going to be the commutative property of addition because we're adding. So y plus 6 using the commutative property of addition is the same as 6 plus y, just switching the order. For the next one, for 5x, 5 times x, that is the same thing as x times 5, commutative property of multiplication. We just change the order. We wouldn't really write it like that though. 5x looks better than x times 5. Next one, 13x plus 8. So using the commutative property of addition, we could say this is equal to 8 plus 13x. We could also use the commutative property of multiplication and say this is 8 plus x times 13. So we flip the order in addition, and then we flip the order in that multiplication term. Okay, so that's the commutative property. So those are just dealing with two terms. The associative property is dealing with three terms. So the associative property of addition is if we're adding three terms. So remember, parentheses first for order of operations. If we're adding a plus b, and then we add c afterwards, that's the same thing as if we add b plus c, and then add a. So that would be this, like, for example, 4 plus 2 plus 5 is equivalent to 2 plus 5 and then adding the 4 afterwards. Okay, so working this out, we would do, on the left-hand side, we would do 4 plus 2, which is 6, plus the 5 is 11. On the right-hand side, we would do 2 plus 5 is 7, plus the 4 is also 11. So once again, probably pretty obvious, but that is the associative property of addition. For the associative property of multiplication, same concept with three terms. If we're multiplying three terms, it doesn't matter which two we multiply first. We can multiply a times b first and then c, or we can multiply b times c first and then a. So something like 6 times 3 and then times 2. So we know that equals 6 times 3 is 18, times 2 is 36. So that's the same thing as saying we multiply 3 times 2 and then times 6. 3 times 2 is 6, times another 6 is 36. So once again, pretty obvious for that. Let's do some examples with simplifying. So the first one here, we want to simplify using the associative properties. We have 3 plus 8 plus x. So the 8 plus x is in parentheses, that's going to be the same as 3 plus 8 and then plus x afterwards. So 3 plus 8 is 11. So 11 plus x. So now it's simplified. Next one, we have 8 times 4x. The 4x is in parentheses, implying that that should be done first. Thanks to the associative property of multiplication, that's the same as 8 times 4 and then times x. So 8 times 4 is 32, so this equals 32x, so 32 times x. Okay, so those ones, probably not that bad. This next one is less obvious, but very, very important. It's the distributive property. So the idea here is that multiplication distributes over addition. So that's going to look something like what we have down here. In parentheses, we have b plus c plus d plus ... however many terms are in there. And then we have the a multiplying everything out front. So to simplify that, we distribute the a into every term inside of those parentheses, and we multiply it. So it's going to be a times b plus a times c plus a times d, and so on for however many terms are in there. So let's do an example here. So we have 6 times x plus 4. So the x plus 4 is in parentheses, the 6 is being multiplied out front. So we have to distribute the 6 to both of those terms. So we have 6 times x, which is just 6x, plus 6 times 4, which is 24. So 6x plus 24. And that's simplified. We just leave it just like that. Next one, we have 5 times 3y plus 7. So we're going to distribute the 5. So 5 times 3 is 15. So that first term is 15y. Plus 5 times 7. So plus 5 times 7 is 35. So 15y plus 35. Next one, we have 4 times z minus 3. So we need to distribute the 4. So it's 4 times z minus 4 times 3. 4 times 3 is 12, so 4z minus 12. Next one, a times 2 plus 5b minus c. So we have to distribute the a into all 3 of those terms. So there's 3 terms in here now. So a times 2 is going to be, we write that as 2a. So we always write the coefficient, the number first, and then try to write the variables in alphabetical order if they're in the same term. So for the next one, a times 5b, I'm going to write that as 5ab. So number is first, coefficient is first, and then a and b are in alphabetical order. And then a times negative c, so that's going to be a times c, so minus ac. Okay, last one here, we have 2 plus y minus z times x. So you can either distribute based off of that, or you can rewrite this as x times 2 plus y minus z. So we can rewrite it this way and write the x first, thanks to the commutative property of multiplication. So I'm going to distribute the x into each term. So x times 2 is 2x. X times y is plus xy. And x times negative z, it's going to give us minus xz. Okay, and that is actually it for chapter 1.6.